Hello everyone, my name is Engineer Minoj Silva, co-founder and director of PROLighting Group Private Limited in Sri Lanka. Today our lighting talks episode series, we are going to discuss about very iconic project in Sri Lanka, which we did 2020 period. So this project client is Road Development Authority Sri Lanka. This project actually funded by JICA from Japan. Main contractor was Sumitomo Mitsui Construction Limited. Electrical contractor was Shin Nippon Lanka Private Limited. Lighting solution provider is PROLighting Group Private Limited. It is us. Manufacturer and solution provided by Linear Light Group from Italy. This is first project in Sri Lanka, that cable bridge lighting theme project in Sri Lanka. Actually, this is second project in South Asia. As I said, the first project in Sri Lanka. This project architectural lighting requirement have been provided by RDA and Mitsui Sumitomo. So technically lighting design and concept has designed by our company. It's been a PROLighting Group, and conceptual support, design support we got from Candela Lighting Design Private Limited. So today topic is bit technical side. So several parties have asked from us to explain this project technically. So today we are going to explain what are the challenges we faced during this project, how we have overcome these challenges, and what are the specialties in this project in lighting application and technology in Sri Lanka. Some technologies we have used in Sri Lanka first time through this project. So let's start.
These images have taken during the testing commissioning of the project. You can see this is the bridge. This is the Kelani Bridge. These columns called pylons and ropes. So there are 4 pylons and that ropes on the bridge. So that 2 type of RGB light fittings have been used to wash the 4 numbers of pylons and cables to create multi-millions of colors in the rainbow spectrum. The fully system, this fully system have been controlled and monitored by an intelligent DMX based lighting control system. Each and every fitting can be individually controlled, means switching, dimming both to create a programmable lighting show at the bridge.
Before we start the design, we have a couple of meetings with the client to understand their requirement and what are the possibilities and challenges when we deliver this project as per client requirement. So this is the bridge basically. So that at the beginning, the client wants to illuminate that entire structure. It means top part, bottom part, including this cable rope as well. So that at the beginning, actually the contractor, because the contract that this project is a design build contract under the contract that Mitsui Sumitomo from Japan. So therefore at the beginning they proposed to the client that single color solution. It means 3000 Kelvin, that warm white solution. So when we had a discussion with the client, so that the client came, they need the color change solution for this bridge, and therefore then we decided that with the budget, so that top part and bottom part or both together we have to illuminate or not. Yeah. With the budget when we consider, then finally we end up with only top part we will illuminate, not the bottom part. There are a couple of reasons for that. Actually, this bridge can be seen when we enter to the bridge. We can see that cable rope and this pylon only to the enter to the bridge. And from city side, we can see that top part of the bridge, both side, basically not the bottom. The reason is bottom is covered by existing bridge for the one side, and other side that the bottom part is not illuminated to the far away. There's no city view from that side. So therefore, we have decided we will only illuminate that top part. So at the beginning, as I explained before, we have a couple of challenges. The main challenge is we did not have this experience before in Sri Lanka to bridge illumination, bridge facade lighting, architectural facade lighting. Therefore, we have studied and we have studied some international references and some case studies when this kind of bridge that illuminating from the lighting. So then we did our literature review. We have studied couple of bridges in the world, and we have talked to our manufacturer from Italy, their experience with the bridges, and some other manufacturers also who we are closely working. So these are some review we did. These are some bridges, so that this is the way this has been illuminated, and the illumination is giving shadow effect to the water surface as well. So this project, the client also like to see that the shadow effect from the water surface. So these are some bridges we have just studied. This is the way that rope is illuminated. This is the way the structures here we call this structure is pylon. That pylon has been illuminated. This is the when it is illuminated. This is the water that the lighting shadow on the water surface. So these are some bridge only that bottom part. There are no structure on the top. That the bottom part illuminated like these are the light fittings. This is the way they have illuminated. These are some bridges. Therefore, we did our literature review on some case studies, and we have shared that our manufacturers have shared their experience of bridge illumination. So now we will move that how we design, how we did using these information, technical information, and client requirements. Then we will move now how we have started design and how we did the design. Now we will move to the design part. When we start the design, so we have used that Dialux software and some lighting softwares to generate lux level report and rendering images and rendering videos. This is the that as I explained before, that first option was single color. It means white light 3000 Kelvin. This was the report we generate for the single color proposal as option 1. These are the images we created using Dialux, different angles, different angles. This is the image on the water. These are the water level, water surface reflection from the light. This is a Dialux report. And I think sometime you might see with comparing rendering images that's using some lighting videos, and this one is a bit different, but this one in the technically more accurate that Dialux software on the lux calculation. So this is the Dialux map on the pylon, that on the pylon. So this is the map. You can see lux 7 level on the pylon, and the pylon side structure. This is the lux level, and later as option 2, we finally have moved to that RGBW solution. These are the lux level images we created using lux Dialux software, and yes, these are some images we use Dialux software to create that. These are the things. This is the video we have generated by Dialux and another lighting software, that rendering softwares into video to explain to the client. This is the kind of rendering video. So before I start this video, I have to explain you the behavior on the lux. When we calculate lux level, that parameters, that behavior on single color and RGBW is completely different. So it means for an example 100 watt, for an example 100 watt single color light, that lumen output is around 10,000, around 10,000 at 100 efficacy. But when it's come to the RGBW 100 dot, it is almost equal to sometimes one third, sometimes 25% of total lumen output. So I will explain that in coming slide using data sheets on the light fittings, why it is different. So this is so see the video now. After complete of dialects and rendering design, we have moved to selection of light fittings. It means type of light fitting numbers, and how it is controls and the control system. So then we have used two type of light fittings for this project. Basically, we have separated the structure two parts. One is pylon, that outer side, it means river sides and inner sides. One light fittings we use. The other light fittings we have used for to illuminate cables parallelly, and side of pylon. So this is the light fittings we have used to illuminate cables and side of pylons. So it is there are two voltages they have mentioned: 174 watt at DC and 190 watt AC. So why there are two voltages? This 174 watt DC is that it is the effective voltage is working with the LED modules. It means for the dialects that lumen levels. So 174 voltage is used to provide illumination of the light, and 190 watt means it is with the driver part, that's with the AC input, but we use for the that effectiveness is 174 watt DC. Some light fittings they will only give a lot of time, manufacturers give only one wattage, it's total power or nominal power, and mainly nominal power, but these fittings they have given two IP rate, IP66, and IK rating. Its mean mechanical strength is working mechanical strength on the fitting is IK8, and DMX control. These are the parameters, main parameters, casting parameters, finishes, diffuser parameters, and bracket details and signals. What are the ports available? See, this is what I have explained before. Later part I will explain. This is so this is, you can see four type of lumen output manufacturer have provided. It means in this LED modules, when RGBW comes, there are four type of LEDs in equal numbers. It means red LEDs, it only illuminate red, other group green, other group blue, other group white. These change in of the percentage and the dimming only, they will it that fittings is releasing different colors we can see from the outside. So this mean this red, when this red LED modules on, others when others off, this lumen output is 1776. When only green LED keeps illuminated at 100% illumination level, it is a 2904 lumen. When it is the only blue, 504. If it is only white LED modules at 3000 Kelvin, it is 2028. So you can see, as I said, that 174 watt at 100 efficacy. Efficacy mean lumen per watt. If it is 100 lumen per watt, this fitting is illuminating this fittings total lumen output, not RGBW. When it is no in the single color option, it will illuminate 17,000 lumen approximately. But now you can see, now it is when RGBW, when fitting is RGBW, that lumen output is very much drop. Yeah, you can see only red 1700 plus, only green very less. When it is given white light, to give white light, this is what 3000 Kelvin white. If it is give 6000 Kelvin, this all keeps to be on in equal. So then mean if generally then this lumen output will be around 6000 to 7000. Yeah, but that one also you can't add these together to get that. You have to get lab report only. You can get this lumen output. That's why when RGBW, when lighting designers and consultant is using RGBW for the facade or any internal areas, normally we are not talking about the lumen output. Or the lux level also not applicable. But for this project, we did as per the requirement, we did. But these things is the experience of lighting designers. For in this project, we did the entire technical design and these things. So this is our experience and our manufacturer experience to select the wattage and etc. So this is one of main challenge for that. For some project, for when we do some projects, there is a time to get light fitting down and do a mock-up. But this project, in the time limit and the production time, we did not have time. Therefore, we basically used our experience and knowledge, and we have add those into the lux level, and that's rendering, and we get some idea to finalize the type of light fittings and the number of light fittings. So that's how we came to that. This is second that second type of light we use for the these fittings we use for the that both side of pile mean river side, outer side, then inner side. One fitting or one fitting, two fittings we use for one pylon, both side, one each side. Yeah, I will explain at another drawing what are the quantities we used. Yeah, you can see in these fittings the manufacturer only give nominal power, which is we use for the lumen output, effective lumen output, and RGBW again. IP60, this fitting is IP67. Now, someone have that question, why IP66 and IP67? So, as per the guideline, IP65 also, that minimum is IP65, but that sometime the manufacturer, that range of that light fitting series, they have IP66, sometime IP67. For this models, they have IP67. 67. So that the previous model they have IP66. That's why we use those things. In this one, they will not. They did not mention their datasheet lumen output, but we knew that lumen output, so it is not, even though it is not mentioned here. So this is the location map we used. This is the pylon. This is the rod. This is the pylon. So there are four pylons on the bridge. So each pylon has 12 cables for each side. This is the pylon. So 12 cable for this side, 12 cable for this side. In that way, we will have, for the entire bridge has 48 cables, and to in single side has 12 cables. To illuminate that 12 cables, we are using only 6 numbers of lights in between the cables. So it means each pylon, each side has a 6 light fittings to illuminate the cables and side of pylons. In that way, we have this kind of light fitting, 24 numbers, and this type of light fittings we have 8 numbers. It means one here outer side, one is inner side. Then each pylon has 2 fittings. It means totally we will end up with 8 light fittings. So this is the address we have, because as you know, this is color change. There's a control system always. So control system always, so that there's a control line also. Therefore, each and every light fittings, we have that different address. Then each and every light fittings we have selected from the program side. And so this is, as you know, this bridge from here to here, signal cable, there's a loop. So it is a couple of couple of kilometers. So therefore, to boost the signal, we have to use boosters. We use this type of boosters. Number of boosters I will show you on a single line diagram. And these boosters we used on the field. It mean on the field through the bridge, and one booster we used inside the master panel as well. And this is the master controller, touch panel type master controller. So these things come in inside at control room. So this is the lighting control panel. So it looks like that. This actual one at the side. So this is the booster, as I explained, one booster we use inside the panel. This is the master controller, that touch panel master controller. So booster is driven by booster driver, master controller drivers. So this is very with now technology has been evolved a lot. Therefore, nowadays this kind of control system, master control panel, is very simple and a couple of items only. So then now we will move to the, I will explain you single line diagram now. I will brief you now about single line diagram. This is the line diagram we have designed for this project. You can see there are 4 pylons, as you are aware already. This is first, second, third, and fourth. So each pylons that we have 2 side of light fittings range, as I explained before. One side has 6 numbers of type 1 light fitting, 1, 2, 3, 4, 5, 6. This is the profile type of light fittings. Each pylon has 2 profile type. This is one is into river side, one is inside the bridge side. So that this is one side, this is other side of the pylon. So this is the system repeating for each pylon in a similar way. So that you can see here these red lines, it's power circuits. 2 power circuits are coming to the one side to power up one side of fittings. It totally 4 circuits are given to one pylon. Then there are four 16 circuits totally there. Then I'm that you can see here that I have mentioned before, there are boosters. We have used boosters to boost the signal due to length of signal cables. So these are the boosters. Each pylon we have used a booster. Then therefore at the field, four boosters. One, two, three, four. And inside the panel, inside master control panel also we use booster, which I shown you before. And this is master control. These devices are inside the master control panel. To that, a part of this power up of this light fittings, also that instead of that we need 230 220 power supply for boosters as well. So we have to power up boosters separately. So you can see, I will explain. Two signal DMX signal cables coming from the master, two lines of signal cables coming from the master control panel. One line is used to pylon 1 and 2. That second line is feed into pylon 3 and 4. So first it is going to the booster at the field. Then after the booster, it is dividing. It is given four distributions line again. This line is giving controls signals to this part, and second one to other side, and again another line is going to that other pylon booster as the input. Then there are again two outputs. One is this side, one is this side. So same system repeating for other side as well. So this is the single line diagram. It is not that much complicated. So this is the way. Now I already explained you the how we came step by step from the illuminate from the design, from photometric. Then we move to the selections, then we move to the single line diagram. This is how we delivered this landmark project in Sri Lanka. This is the still one and only bridge architectural lighting bridge project in Sri Lanka. Thank you very much. So we will meet again from another episode to discuss about another technical matters or another nice project. Thank you very much.